my name is Fernanda Sobral, and today I'm going to solve the laboratory diagnosis quiz we made last week. So, question 1 says, in the laboratory the speed of light c can be experimentally obtained and it is ensured that the measurement is not greater than 3.000 times 10 to the 8 meters per second, no less than 2.996 times 10 to the 8 meters per second. What is the absolute uncertainty and central value of this measurement? So, as we know, the central value should be the value that is right between these, or the average between them. So it should be 2.998 times 10 to the 8 plus minus, and we should add as an uncertainty the value that make us reach the higher and by subtracting the lower. So that is 0.00, only zeros, 2, and this is all in meters by second. So that is the answer to question number 1. Question number 2 says the length of a pencil was measured with 2 different apparatus, obtaining the following results. A equals 11.5 plus minus 0.05 and B equals 11.485 plus minus 0.0005. In theory, the length should be 11.5 centimeters, which measure was much more accurate. So even though measure A appears to be more accurate as it is closer, apparently, as the central value is closer to the real value, that is not true. The actually more accurate measure is measure B, as it has a lower uncertainty and less likelihood to vary a lot from the real value. Question number 3 says the correlation coefficient determines. So as we know, this coefficient determines how close a trend curve is to the sample. So the answer should be the dispersion between the sample and trend curve. So question 4 says the least square method always determines, and the answer to this one is that it determines a mathematical model that is the closest to the sample we have. And well, in this case it is expressed as a mathematical model with the least dispersion between the sample and the field. So that is the answer for question 4. Question number 5, if the dispersion between the sample and the trend curve is large, this is because this has to do again with the correlation coefficient. When the trend curve is exactly adapted to the sample, the correlation coefficient equals 1. And for this to be the opposite, that it has like nothing to do with each other, it must be a value much smaller than 1, like, I don't know, 0.0001. The value can never be 0, therefore the answer is not 0, but a value way smaller than 1. Question number 6, we have a pipe whose diameter d equals central value of d plus minus the uncertainty of d. Then the absolute uncertainty on the cross-sectional area, which equals pi times d divided by 2 to the square, is obtained from the equation. So as we know, there is a formula to obtain this, which states that whenever you have something rise to the second power, the absolute uncertainty is that value multiplied by 2. So in this case, this would be our answer, this one right here. So that is question number 6. Question number 7, we want to obtain the value of gravity from the time t, which equals central value of t, plus minus the absolute uncertainty of this value. That it takes for an object to make an oscillation when it is tied to a string of length L, which equals the central value of L plus minus the uncertainty of L, where it moves like when it moves like a pendulum. If we know that G equals 4 times pi to the square, which should be a constant, times L divided by T squared, what is the value of the absolute uncertainty of G? So in this case, we know that first we need to apply the rule for the square, and then when we have that value, apply it for the division. So at the end, we end up having something like this. Oh yes, I don't know if that looks fine to you. The value of the absolute uncertainty should equal, first of all, this constant we have right here, which should never change. This should be divided by the central value of c to the square, and all of this multiplied by the uncertainty of L plus 2 times the central value of L times the uncertainty of t divided by the central value of c. So this is what we obtain after first obtaining the absolute uncertainty for t to the square, and then obtaining it for the division, which as we know relates the value above with the uncertainty of the value below with the uncertainty of the value above, and then all divided by the value below. So that is the answer in this case. Well, question number 8 says, students A and B made 5 measurements of the same experimental physical variable with the same instrument calibrated correctly. They make calculations and they find that the average of the measurements made by student A is more exact than the average of the measurements made by student B. This means that, this should mean that the value obtained by student A is closer to the actual value of the measurement obtained. So this is expressed in the answer that says the percentage error of the average of student A's measurement is less than the percentage of error of the average of student B measurement, which means that students A measurements were not much, but closer to the actual value. That's what more exact means. Question number 9. To determine the absolute uncertainty of an indirect measure, we should calculate, and the answer is the derivative of the function. As we know, an indirect measure is when we use direct measures we obtain through using instruments to apply certain calculations and obtain an indirect measure. And its absolute uncertainty is obtained, as I said before, by the differential of the function. So question number 10. Which of the following parameters are dimensionless? Standard deviation is not dimensionless. Correlation coefficient, it is dimensionless as it is a coefficient. It has no units, for it expresses a relationship. Error rate has no units either, as it also is calculated through sort of a relation. The differential of the function, it has units, as we know from past experience in the course. Whenever you differentiate something, you can also differentiate the units. Absolute uncertainty, it has the units of the central value it accompanies, but relative uncertainty does not, as it is also a relationship. So the answer is correlation coefficient, error rate, and relative uncertainty. Those are the dimensionless amounts on this list. Question number 11. Which of the following parameters is used to estimate or determine the relative degrees of precision of a measure that was the result of an average? And the answer is the standard deviation. As we know, this value calculates how close data are to the mean. So for example, if we have a curve like this, so our data are all around, we know that, for example, these data are at this distance, but these are a little bit farther, these are a little bit closer. So standard deviation helps us know overall how close our whole data is to the mean value. So question number 12, a systematic error is characterized by, as we know, systematic errors are normally errors made in the procedure, in the design, or in the use of instruments. So it is repeated with every repetition of the experiment. So this means that the error will be carried through the experiment. So the answer in this case is for causing measurements that have the same degree of error. The good thing about this is that once you realize you have this error, you can change it in time, and it makes it simpler because this one error will affect everything, but it will also correct everything once you realize you have that error. So question number 13. Sorry. The speed at which a wave travels along a string is given by the equation v equals f divided by mu, the square root of that, so it goes like this. The experimental variables are the tension force F and the velocity of the wave v, the linear density of the string mu, mass by length is a constant. If we apply the following change of variable where y equals f and x equals v to the square, so that we have x equals y divided by mu, so that y equals mu times x, which is a straight line, such that the graph of these new variables y and x are in the type of y equals mx plus b. So here we could have a constant b. What are the units of the slope m, which in this case is represented by mu, and the y-intercept b? So as we know, as this is a value of mu and it is in terms of mass and length, the unit should be expressed as kilogram per meter. So when it's added up to v squared, which is meter per second to the second power, these should become newtons, which are the units for a force, which should be also the units for b. As is an addition, it must carry out the same units, so this is the answer. The units of the slope should be kilogram per meter, and the units of the y-intercept should be newtons. So question number 14 says we have a tamalito hanging from a spring, and we know that its angular frequency is given by the equation W equals K divided by M, and this square root. Here K is the spring constant if the experimental variables are the mass M of the tamalito hanging from the spring and the frequency W, what is in theory the relationship between the variables M and W. So this is very similar to what we just saw before, and with a few changes it is actually a linear relationship. So that is the answer in this case. And question number 15 says, when a body is immersed in a fluid such as water, the pressure exerted by this liquid on the surface of the body with which it is in contact is defined as P equals F divided by A. Pressure equals force divided by area. If the experimental variables are the force exerted F and the area A, while the pressure P is a constant, then in theory the plot F versus A would be A. So what we need to do here is just separate these variables, so it ends up being force equals A times P, which P is a constant, and this is a form of a straight line, where P is the slope. So that is the answer for question number 15, and that's the end of this quiz. Thank you very much.